Okay, YouTube, this is my last video in factoring in which we're going to explore one more special factoring pattern. In the last video, we looked at differences of squares. In this video, we're going to look at what we call perfect square trinomials. And so we say this second special factoring pattern, we do refer to these as a perfect square trinomial, but because what we have really is the result of taking the perfect square of some binomial, okay? So in either instance here, basically we're going to start by considering multiplying a binomial times itself, which will give us a three-term thing, a trinomial. But the reason why we call it a perfect square trinomial, again, is because we're multiplying something times itself to get that trinomial. So in this x plus 3 case, what I want to look at here is this. When we FOIL this out, do we notice anything special about the trinomial we get? And I want you to understand that this is very similar to a difference of squares, except for instead of x plus 3x minus 3, they're identical. So we would get x times itself. So we do get a square on the front. And we'd say now we get 3x and then 3x, and then we would get plus 9. So I want you to notice that the first term here is a perfect square of this value, and the last term here is a perfect square of this value. But the middle term, what we're going to get that from is essentially by saying we get 3x twice. We get 2 times x times 3. So we'd say this is a 6x plus 9. And this is what's referred to as a perfect square trinomial, but only because we squared a binomial to get it. It's a result of squaring something. So when we look at 2x plus 5 squared, let's be careful here. By the way, 2x plus 5 squared does not equal 2x squared plus 5 squared. That's a common mistake. What we need to do is we need to write this out. When in doubt, write it out. We say 2x plus 5 times 2x plus 5. And let's look at what we get here. Again, we're taking 2x times itself. So we're really going to get a perfect square in the front. And then we'd say, well, I'm going to get 2x times 5, but I'm going to do this twice. So I'm really going to get 10x plus another 10x, and then we would end up with this. We would say plus now in the back 5 times itself, and it would be positive, okay, in this case. So looking at this, looks like we get a perfect square in the front, a perfect square in the back, but 2 times 2x times 5, okay? So we really get 20 of these x's here, plus 25 constant. So this is also a perfect square trinomial. So things of note here, when you have a perfect square trinomial pattern, that is these things over here, it's the result of taking a binomial times itself. And it's either a plus b times itself, this should be a plus b, or a minus b times itself, so a minus b. So what we notice here is we always get in the front of our trinomial this first thing times itself, so like a times a is in the front. And then in the back of this trinomial, we get b times b, which is really just this term times itself. But in the middle, we notice that every single time, like ab here and ab, we're going to happen to get that twice. So really, we're always promised to get this middle term as 2 times whatever a is times b is. And then likewise here, you'll notice the only difference between these two trinomials here in this special pattern is that here we would have negative ab and negative ab twice. So we'd have negative 2 times this times this. But the front number or front value is the square of this leading a, and the back value here is the square of this trailing b. So looking at all of these down here, I'm going to go ahead and tell you that these are all perfect square trinomials, but we want to factor them. So one thing to keep in mind is this. If you forget that this is a perfect square trinomial, or you have a hard time recognizing it, then we could at least say, look, it's a trinomial where a is 1. So can we think of two numbers that multiply out to be a positive 25 and add up to be a 10? I can think of two. They'd be a positive 5 and a positive 5. I want you to understand, though, we could call this an x plus 5 times itself. So this is a perfect square trinomial. So my job in this video, hopefully, is to explain to you how do you recognize a perfect square trinomial. In the same way you recognize a difference of squares, something like maybe 16x squared minus 25, as your brain should go ding, 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 these are squares. So I'm saying look at your leading term. Okay, we said when you take a binomial times itself, we get a leading square here and a trailing square. So x squared is a perfect square of what? Well, of x. So maybe that goes in the front here. And I say, notice that 25 is a perfect square of what? 5. So the other thing I want to notice is this. If this is a perfect square trinomial, then I would get 2 times this as my middle term. And I notice that x times 5 is 5x. If we double that, we get 10x. So this is indeed the factored expression here that goes with this. Looking on to our next one here, I notice that 25x squared and 64 are perfect squares. So in this case, our a would be like 5x. That would be our front thing in this binomial here. And our b would be, well, what can I take times itself to get 64? It would be 8. And I want to notice here in the middle, if I were to get 2 times 5x times 8, then what we would have here is 2 times 5x is 10x times 8 is 80x. The only difference here is that it's a difference here. So what we're going to end up with is really this. We're going to say, well, I put 5x in the front and 5x in the front here. We'll put an 8 here and an 8 here. It's just that we'll make these both negative. Okay, so 2 times 5x times negative 8 would give us this negative 80x. And again, I noticed that here, hey, perfect square, this might be a perfect square trinomial. In this instance, our a and our b would respectively be, well, 3x for our a, because that times itself is 9x squared, and then 7 for our b, because 7 times itself is 49. My question is, if I take 2 times 7 times 3x, which, by the way, 7 times 3x is 21x, and I double that, I get 42. I do indeed get this. So this must be a perfect square trinomial, and we could write this as 3x in the front, and then 7 in the rear. And since this was positive right here, we'll say that these were both positive. And just to look forward to further sections in the future here, we could write this as 3x plus 7 squared. Cheers.